Continuing with the lesson on the law of cosines, we left off with the second problem. The three angles are listed as you see on the screen. Of course, they have to add up to 180 degrees. We found angle A, we found angle C. If you were to add the two together and then subtract from 180, you'd find angle B is 26.4. The last problem is an application. A boat is going from Naples, Florida to Key West, 150 miles away. You can see on this blue line here. Maintaining a constant speed of 15 miles per hour, but the boat encounters heavy crosswinds and strong currents. After 4 hours, the boat's off course by 20 degrees. Now, as you look at the picture, you can see right here, as I'm tracing over, that this would indicate a path that's 20 degrees off course. They've written in the 60 though. Distance is equal to rate times time, as you can see I'm writing up here. If they're traveling 15 miles per hour, going 4 hours, that of course is where the 60 is going to come from. So of course we have this triangle. You can even jot this off to the side here. 60 miles, here's 20 degrees that they veered off course. Here's 150 miles. X right here would be the distance that the boat is from Key West. And they'd like for you to find how far that distance is. How far is that sailboat to Key West at the time? Law of cosines once again. Law of cosines, I don't even have to label this triangle. You're more than welcome to do so. But look for a side angle side given information and a missing side that's directly across from that included angle. That unknown side here, this x squared, is the one that is isolated. So x squared would equal 60 squared plus 150 squared minus 2 times 60 times 150 times the cosine of 20 degrees. And of course we can take a square root on both sides. And here's the wonderful thing, the calculator, in all truth, becomes such a wonderful tool for us. It will allow us to do this problem. You don't have to square the 60 or the 150 individually even. You can plain and simply just get this all typed out. And don't forget to check that your mode is on degrees. That's a common confusion for students. They might say, wow, I typed everything in. I'm not getting what you had. But you'd see that after taking that square root, it's about 95.8 miles. So that's part A. Now for part B, and we can write 95.8 right in here. For part B, they're saying through what angle should the sailboat turn to correct its course? And as we're looking at that triangle there, it might be a little confusing for kids as they're looking at that angle A that has an arrow in it. Angle A is an obtuse angle. If you really think about it, this boat only veered off 20 degrees from its directed target. An obtuse angle, that's really making a huge angle. Honestly, you're going to be looking for theta here instead. Here's a way I'd like to maybe make it a little bit more clear. I hope it's going to be a little bit more clear. Let's just say that the boat's right here in yellow. The boat's going to have to turn a relatively small angle to go back on the correct course. If a boat's turning a huge amount, more than 90 degrees, that's getting close. As you get closer to 180 degrees, you're pretty much almost reversing direction entirely. So we're actually going to look for this angle A and then take the supplement to find theta, do 180 minus that. So as you're looking at this triangle right here, here's our angle A. You can see that that's right across from the 150. So we can say 150 squared would equal x squared plus 60 squared minus 2 times x times 60 times the cosine of angle A. Now, by the way, something that I did not do, and it's actually a very smart thing to do, is right now I'm actually going to go back to my calculator and press the store button and put it in for x, so that later on I don't have to retype a 95.8, which would have round off error, of course. X is going to store that value in its entirety. So we're going to do a little bit of moving terms around here. If I move the 2x times 60 with the cosine of A to the left side, I could also then subtract the 150 squared. And then just doing a little bit of cleaning up, we can say the cosine of A would be x squared plus 60 squared minus 150 squared, all over a 2 and an x and a 60. And notice I didn't even do 2 times 60 is 120 to simplify it. In all truth, you don't even have to. You could just go straight to your fraction button here and type in x squared plus 60 squared minus 150 and square that. Down below we'll have 2 times x times 60. And you can see that's about negative 0.844, something like that. And if you wanted to write that down, you certainly could. You don't even need to do that, in all honesty, because right now you just have to take the inverse cosine of that value. You could do that directly on your calculator. You could just say inverse cosine, second answer, and you can see you get about 147.6. So angle A is about 147.6 degrees. What's theta though? What's the angle that the boat would really have to make a correction angle on? The boat would have to turn the supplement of that 32.4 degrees. Okay, 32.4, and then you're good to go. So one final question here. How much time has been added to the trip because of this? And you assume that the speed remains at 15 miles per hour. Well, if you were to just do a basic distance equals rate times time, and we're always going to have 15 miles per hour, originally you can say, well, there were 150 miles between the port where we were leaving at Florida, going to our destination. 150 equals 15t, t would equal 10. Really, you should be traveling 10 hours. But now, because of the correction, once they noticed that they were off course, you can notice that they were traveling 60 and x. They had to go 60 right here, and then they have to come back 95.8. So that's really 60 plus 95.8. That's your distance. Your rate is still 15. And that's 155.8. Hey, we can divide that on our calculator real quickly. 155.8 divided by 15. And you can see it's about 10.4 hours, roughly. So how much time is added? We've got 0.4 hours added time. So not horrendous. Obviously there's 60 minutes in an hour, and 0.4 times 60 is 24, so about 24 minutes. Okay, so the homework's going to be right here on page 535, 21 through 41 every other odd, and then 43, 45, and 51.